Alright, so good day everybody. I welcome you back to Ajaks Tutorials YouTube channels. My name is Ajaks. I'm the CEO founder Ajaks Tutorials. And in today's video, we're going to be looking at chemistry, stoichiometry 2.0. Alright, so if you have not watched stoichiometry 1.0, it is on your screen. After this video, please check it out. Alright, and in this stoichiometry 2.0, trust me, make sure you watch this video till the end because we're going to be doing a lot of things in this video. We're going to look at percentage composition, empirical formula and molecular formula, and we're going to solve 26 JAMB questions on this particular topic. Now, it might seem confusing, but trust me, if you follow from the beginning down to the end of this video, empirical formula, molecular formula, percentage composition, any question JAMB want to ask you under this segment, you're going to trash it. All right, so let's start. First of all, in the previous video, we established so many formulas on mole. All right, we said mole is basically the mass of a substance divided by the molar mass. Moles is the number of particles, ions, atoms, or elements divided by what? The Avogadro's number. And we said mole is what? Volume of a substance over what? Volume at STP. All right, so that's basically what we did in the previous video. Now, in today's stoichiometry 2.0, this under chemical formula, we're going to be looking at percentage composition, empirical formula, molecular formula. So let's start. First of all, you're going to see it on your screen. First of all, what is percentage composition? So please, this is either called percentage by mass or percentage composition. Anyone is fine. Now, it's on your screen. Percentage by mass or composition tells us how much of each element is present in a compound by weight. Is that clear? It is often determined or obtained experimentally. Now, that's just English, all right? But it's good you understand that. It basically tells you how much each element, what, is present in a compound. Now, let's look at something very interesting. I have a series of examples, then we'll treat real JAMB questions. Now, my example 1 under this percentage composition. So, example 1. Now, the question says, you see it on your screen, find the percentage composition of all the elements in H2O. So H2O is water, H2O, right? H2O is water. So we have to look for the percentage composition of all the elements here. Now, the formula for percentage composition, I will show you the steps. Just listen attentively. So this H2O now, first thing you need to do is to find the molar mass of H2O. Do you understand? Now, what's the molar mass of H2O? Molar mass of H2O is what? We have done this in the previous video. This gives me 2 plus 16. Oxygen is 16. So 2 plus 16 is what? 18, right? So 18 grams per what? Mole. Now, let's start. For hydrogen, we have to look for the percentage composition of hydrogen present here. All right? And percentage composition of, see, listen attentively. The total percentage composition of each element in a compound must give you 100%. Okay? So, because our answers are going to be in percentage. So just note that the percentage composition of hydrogen here plus oxygen must give you 100. All right, so let's come back to this. So now, so hydrogen, what's the molar mass of hydrogen present here? 2 times 1, right? You divide by the total molar mass, 18. You multiply by 100. Class, this gives you what? Let's press it together. This 100% because we're looking at what? Percentage composition. Do you understand? Good. So 2 over 18 times 100. So this gives me what? 11.11% for hydrogen. I hope this is clear. Now let's look for the percentage composition of oxygen. So this, how many atoms of oxygen are present here? 1. The reason I put 2 here is because the atoms of hydrogen present in water is what? 2. So this is 1 times what? 16. That's the relative atomic mass. We have done all these things in series 1. So please just check series 1. Series 1 is like where we laid a lot of foundation. So divided by still this molar mass. And I'm multiplying by what? 100%. And this gives me what? Let's press 16 divided by 8 divided by 18 times 100. This gives me 88 point approximately 9%. Class, when you sum these two up, what is it giving you? 100. So please note that the percentage by mass of each element in a compound must give you 100%. Okay, so the step is very simple. Firstly, you take the molar mass of the hydrogen present in water. That's 2 times 1. Then you divide it by the total molar mass. Then you multiply by 100%. You do the same thing too for oxygen. 1 times 16 divided by 18 times 100. All right, let's look at one more example before we move to the next part. Then we'll solve a lot of questions. Don't worry. This is just, I'm just laying foundation. Now let's look at example 2. So you see it on your screen now. So it says calculate the percentage composition of carbon and percentage composition of all the elements in calcium triazocarbonate 4, CaCO3. All right. So now let's do it. Let's start with calcium. So you know this guy has carbon equal to 12, oxygen equal to 16, calcium equal to 40. So they are the relative atomic masses, RAM. Okay, we have done that in the previous video. Okay, now calcium. What's the molar mass of calcium present in CaCO3? 40. Divided by, so when you want to find the total molar mass of this calcium triazocarbonate 4, let's quickly do it here. So CaCO3 is going to give you, this is 40, right? Plus this is 12, plus this is 3 times 16, 48, right? So this gives you 100 grams per watt mole. Now we are done with this guy. Okay, now put this 100 here, then multiply by 100%. So this will give you the percentage composition of calcium. So let's do that. In fact, this is 40 because 100 cancels 100, so 40%. So calcium is 40. Now let's look at carbon. Carbon will give me what? What's carbon here? 12. See, let me tell you something. It is not the relative atomic mass that you put here. What is meant to be here is the molar mass of the element present in the compound. Good. So the reason I said that thing was 12 because carbon is just having one atom in CaCO3. So this is what? 1 times 12 divided by what? The total molar mass 100 times 100%. So this still give me what? 12%. So carbon is what? 12%. All right. Now, what's the last one? Oxygen. Oxygen is 3 times 16 divided by what? 100 times 100%. So this gives me what? 48%. Now, class, add it up. Add it up. 48 plus 12 plus 40 gives me what? 100. Okay. So that is basically how to find percentage composition of an element in the compound. Now, we're going to solve a lot of questions now. We're going to solve 14 questions, 14 real JAMB questions on this particular aspect. So please make sure you follow up. See, don't ever forget it. The formula for percentage composition is what? The molar mass of the compound, of the molar mass of the elements in the compound, all right, divided by what? The molar mass of the compound. So you multiply by this guy by 100%. So this is the formula for what? Percentage composition. Now let's solve questions. Question 1. All right, so welcome back. Now question 1 will appear on your screen now, and it says, what is the percentage by mass of oxygen in magnesium oxide? So what's the percentage by mass of oxygen in magnesium oxide? So first of all, magnesium oxide is MgO, right? This is magnesium oxide. So what's the percentage by mass of oxygen here? So what do you do? So this is my question 1. So what do? They gave you that magnesium is 24 and oxygen is 16, right? So what do? You just say 16 because for oxygen, the molar mass of oxygen here is 1 times 16, right? Divided by the molar mass of magnesium totally. I mean, the molar mass of magnesium oxide. So this gives me, this magnesium here is 24 plus what? 16, right? So that's basically it. All right. So I hope that makes sense. So what do? This is 16 divided by what? 24 plus 16. Press. That's 40. So multiply this whole thing by 100%. So class, what's the answer? Oxygen. This is 1 year. Okay, let's just do it. 16 divided by 40 times 100. So The percentage composition of oxygen, or percentage by mass of oxygen, is what? 40%. I hope that makes sense. Very, very simple. Option B is correct. Now, quickly, let's move to question 2. Question 2 appears on your screen now, and it says, calculate the percentage of carbon in CO2. So this is CO2. The percentage of carbon is CO2. So how will you do that? Carbon is what? 1 times 12 divided by, this is 12 plus, this is what? 16 times 2. Do you understand? That's 2. So this give me 12 divided by what? 44. You change this to percentage. What is it going to give you? Press 12 divided by 44. See, I want you to be pausing the video, try it, pause the video, try it. So 12 divided by 44 times 100. That's giving me 27.27%. Yes. So 27.27 or 27.3. Yes, 27.3 is the answer. And for my option C is correct. I hope that's clear. Very, very simple. Question 3. You see it on your screen now. Now, question 3 says, determine the percentage of calcium in calcium triazocarbonate 4. So calcium triazocarbonate 4 is, we have calculated it before. If you go and check, the molar mass of this one is 100. So let's not waste our time. 100 gram per mole. Right? Okay. Now, we're looking for calcium in this guy. We have done it safe. So this gives me what? 40 divided by 100. That's the molar mass times 100%. Very simple. So this gives me what? 40%. Alright, question 4. You see it on your screen now. The percentage by mass of hydrogen in ammonium chloride is, so please always know how to name compounds. All right, it's very, very important. So ammonium chloride is NH4Cl. This is ammonium chloride. So we're looking for the percentage by mass of hydrogen here. So first of all, let's find the molar mass of ammonium chloride. This gives me, this is 14 plus this is 4 times 1, 4 plus this is 35.5 chlorine. It was given our here. So when you sum this thing up, what's it going to give you? Let's press with me. 14 plus 4 plus 35.5. This gives me 53.5. So gram per mole. So that's the molar mass of this guy. Okay? But we're looking for the percentage by mass. So percentage by mass of hydrogen. That's what? 4 times 1. That's 4, right? The molar mass of the element divided by the molar mass of the compound. So what's the compound? 53.5 times 100%. So this gives me what? Press. 4 divided by 53.5. So multiply that guy by 100. That's 7.47%. Okay? Yes, 7.47 or 7.48 rather. So approximately 7.5. Option B is correct. So how this is clear? Very, very simple. Alright, so question 5. You see it on your screen now. Question 5 says, find a hair. It's getting more interesting. Listen. Find the percentage of nitrogen. Find the percentage of nitrogen in ammonium sulfate. So ammonium sulfate is giving us NH4 into bracket 2. Okay, I'll slow down here a bit. SO4. Yes, so this is ammonium sulfate. So we're looking for the percentage by mass of nitrogen. Now, percentage by mass of nitrogen in this guy. So first of all, let's find the molar mass of this ammonium sulfate. Okay, so the molar mass of this whole thing will be equal to. So nitrogen now, normally, listen, normally nitrogen is 14. And it's having one atom here. So it's 14 times 1. But look at this 2 that is outside. So that is going to still multiply this thing. Do you understand? So this is giving me 14 times 2 instead. That's 28. Plus, so hydrogen, the relative atomic mass of hydrogen is what? 1. Times the 4 atoms, that's 4. Multiply by these 2 outside, that's 8. right? Plus sulfur 32. Normally sulfur is 32. It was given in the question, even if you don't know the ROM, everything was given there. So sulfur is 32 times 1 atom, 1, that's 32, right? Plus oxygen is what? Oxygen is 16. 16 times the 4 atoms there is what? 64. Good. So this gives me what? So the molar mass will be equal to, so let's add this up, guys. Let's add this up. 28 plus 8 plus 32 plus 64. That's 132, right? So 132 grams per mole. So of this whole compound. But the question says, find the molar mass, the percentage composition of nitrogen. So what is the molar mass of nitrogen in this compound? Class, 28. So the percentage by mass of nitrogen is what? 28 divided by what? 132 multiplied by 100%. And this gives me what, class? Press. 28 divided by 132 times 100. 21.2%. Good. 21.2%. Option C is correct. Okay, so this is very, very simple. Very cheap. Now, this is the first important 5. The first basic 5. Now, let's move to the next Ogbonge 5. Okay? 2026 Jambites come close. In 2025, Ajaks tutorials produced 239 students with 300 plus. And we had our top student emerging top 8 in Nigeria, 372 over 400, as Onyeme Samuel. Now, over the years, I've understood that many students that fail JAMB, they don't fail JAMB because they don't read. Alright? Many of them, they don't have the right guidance. Ajaks tutorials 2026 JAMB classes is going to be starting January 5th and runs down till your examination. The fee for this class is 8,000 naira monthly. We have other plans for you. In case your parent or guardian want to pay for more than a month, we have the plan for you. To be a part, click the link below now, text number on your screen. Remember, in 2025, we have 239 300 plus. 2026 will not be any different. Class is for science students only, and class holds online. We use WhatsApp, Telegram, YouTube, and our mock portal for our classes. Click the link below now or text number on your screen to make inquiries and enroll. Have a lovely day. Bye. Question 6. You're going to see the question on your screen now. Question 6 says, what is the percentage by mass of water of crystallization? Listen, in copper 2 tetraoxosulfate 6 pentahydrate. So penta means 5, tri means 3, mono means 1, hept means 7, hex means 6. Do you understand? Oct means 10. No, oct means 8, dec means 10, non means 9, like that. Okay, so copper 2 CuSO4 dot pentahydrate. This is a water of crystallization. So we are asked to look for the percentage by mass of the water in this particular compound. Now, first of all, let's find, we'll do this one step by step. I thought that the formula for percentage by mass, so percentage by mass of the water of crystallization in this compound will be equal to the molar mass of the water of crystallization divided by what? The molar mass of the compound. Okay, so firstly, let's find the molar mass of the whole compound. All right, so just pay attention. CuSO4 dot 5H2O. Now, this is going to give me, so in your exam, anytime you want to calculate molar mass of a water of crystallization salt, this is actually a salt. Okay, this dot means you have to plus it. Okay, good. And this 5 means it's covering the whole thing. So CuSO4 dot 5H2O. Copper is what? Let's do it here rather. Copper is what? 64. They gave you now. Check. They gave you. Okay. So copper is 64 plus sulfur is 32. Do you understand? 32. I want to stay here so that you guys can see me. So 32 plus oxygen is 4 times 16. That's 64 again. Now this dot means plus. Do you understand? 5 into brackets. Can you see what I'm doing now? 5 into bracket, not plus 5. No. 5 into bracket, or you can basically say this hydrogen now is 2 here, right? So 2 multiplied by this 5 is 10. So 10 times the relative atomic number of hydrogen, which is 1, that's 10. You can do that. Or you basically say 5 bracket 2 plus, like that. Okay? So plus oxygen, 1 atom. Do you understand? But this 5 is making it seem as if it's having 5 atom present here. So it's going to be 5 times 16. So let's press 5 times 16 what? You know why I put 16? 16 is the relative atomic mass of oxygen. So 5 times 16 is 80. Do you understand? Now let's sum this whole thing together. Let's sum this up. So this is 64 plus 32 plus 64 again plus 10 plus 80. That's 250. So this is 250 grams per mole. I need to change this marker. Alright, so 250 grams per mole. Hold on. Okay, so 250 grams per mole is the molar mass of this. So I've gotten this part. Now, what's the molar mass of water? Listen, the molar mass of water in the crystallization salt. So this is what we're looking for. So normally water is H2O, and this is 2 plus 16. 2 plus 16 is 18. So 18 times 5, you must add that 5. So 18 times 5 is the molar mass of water. So what's 18 times 5? Press 90, right? So 90. So 90, this is 90, and this is what? 250. So we can get the percentage by mass of the water of crystallization salt in it. Okay? So what's now going to be? So the percentage by mass finally will be equal to, this is 90, and this is 250. Okay? So 90 divided by 250 times 100%. And this gives me what? 90 divided by 250 times 100. This gives me 36%. Yes, 36%. And for my option C is correct. I hope that's clear. Very, very simple. All right. So now let's look at question 7. You see it on your screen now. So question 7 says, calculate the percentage of sodium. Let me show you this is recording now. Alright, so now welcome back. Let's move to question 7. So question 7 says, you see it on your screen now, calculate the percentage of sodium in sodium thiazocarbonate decahydrate. Alright, so sodium this is actually carbonate 4. So decahydrate. Now deca means 10. I told you. So in case you don't know, just know now that this 5 is penta. Pent is 5. Do you understand? Hept is 7. Hex is 6. Dec is 10. So sodium thiazocarbonate 4 decahydrate means Na2CO3. This is sodium thiazocarbonate 4 dot 10 water of crystallization. This is what it means. Okay, so we have to look for the percentage by mass of what? Sodium. All right, so of sodium. So let's do that now. We're still using this formula, the molar mass of sodium divided by the molar mass of the compound. So let's find the molar mass of the compound. So mm of the compound will be equal to, let me say compound now so you guys don't think it's carbon. Compound is going to be equal to, so this is giving me, we don't have that space, so just know that it's molar mass I'm looking for. So this is giving me 2 multiplied by 32, 23 rather. Sodium is 23. All right, plus carbon is 12 multiplied by 1, plus oxygen is 3 multiplied by what? 16, plus 10 into brackets. I want to do different way. You know, in this one I just did it straight, but let's put it into brackets first. So plus 10 into brackets. This water, just know that H2O is 18 because it's 2 and it's 16, so 18. So everything is going to be equal to. So this gives me 46 This gives me 12. This gives me 48. And this gives me what? 180. Right? So what's the molar mass finally? So the molar mass of this compound is equal to, so let's add that. Let's add it up. So it's going to give me 46 plus 12 plus 48 plus 180. All right, so that's giving me 286, right? So 286 is the molar mass of the entire compound. So 286 grams per mole. I hope you are solving with me. Now, what's the molar mass of sodium present? So the percentage by mass of sodium will now be equal to, so what's the molar mass of sodium present? 2 times 23. Right? Sodium is 23, don't forget that. Okay? Divided by the total. Times what? 100%. Alright, so this gives me percentage by mass of sodium to be equal to 2 times 23, which is 46, divided by 286 times 100. So the answer is what? 16.1%. And for my option B is correct. Good. So I hope this is very, very clear. All right. It's very, very simple. Just try your best to first calculate the molar mass. Then once you have done that, don't go and make mistake and say sodium is 23. Now put 23 here. Don't forget, there are 2 atoms of sodium here, so you have to include it when finding the percentage by mass. Do you understand? So this is the percentage by mass of sodium. And even you did not put the 2 now, that means what you are going to be getting is the percentage by mass of 2 sodium. No, sorry, of half sodium in this thing. Do you understand? So please don't forget. Always make sure that you understand what I'm trying to say. All right? And if you have questions at all, just ask in the comment box. So let's move to question 8. Question 8 will appear on your screen now. And question 8 says, find the percentage by mass of oxygen in aluminium triisonitrate 5. So aluminium triisonitrate 5 is AlNO3 into bracket 2 here, all right, because this is not looking correct. 3, because aluminium has the valency of 3, and this NO3 is a radical. Okay, it has a valence in a charge of -1. All right, so AlNO3 into bracket 3. We're looking for the percentage by mass of what? Of oxygen. So first of all, the molar mass, we are going to be faster now. The molar mass of this guy is what? So aluminium on its own is Al, and it has a relative atomic mass of what? 27, right? So plus, now listen attentively, this 3 that is out here, multiplying this nitrogen here, so it's going to be 3 times the relative atomic mass of nitrogen. So what's the relative atomic mass of nitrogen? 14. So 3 times 14, that gives me 48. 42 rather. All right. Now 3 times 3 here is 9. So 9 multiplied by the relative atomic mass of oxygen. 9 times what? 16. That gives me 144. So it means that this thing is a molar mass of oxygen. No, don't forget, this was oxygen, this was nitrogen, and this was what? Aluminium. So we're not going to calculate again. We'll use this one straight. Now, let's sum this thing up. I'm teaching you how to be fast in your JAMB. Okay? So 27 plus 42 plus 144, this gives me what? 213 grams per mole. All right? So what's the percentage by mass of oxygen? 144 divided by 213 times 100%. So my percentage by mass of oxygen is equal to, so 144 divided by 213 times 100. That's 67.6%. So 67.6% is correct. Option C. Very, very simple. You can see it's very cheap. Let's move Question 9, you see it on your screen now to appear there. Question 9. Question 9 says the percentage by mass of chlorine in sodium triacylchloride 5, that's sodium triacylchloride 5, NaClO3, all right, so NaClO3 is, so we're looking for the percentage by mass of chlorine here. Do you understand? So first of all, let's quickly find the molar mass of this guy. This is 23, right? Sodium. Plus, this is what? 35.5. Plus, now this is O3. Oxygen is 16, so 16 times 2 is 48. What's this whole thing giving me? Let's press. 35.5 plus 23 plus 48. This is 106.5 grams per mole. So remember, what I'm looking for? It's supposed to find the percentage by mass of chlorine. This is chlorine. Do you understand? So always don't be having to calculate it separately. It's clear. That's 5.5 times 1. So percentage by mass of chlorine is equal to 35.5 divided by what? 106.5 times 100%. So what's my answer finally? Percentage by mass of chlorine will be equal to, so 35.5, press your calculator, don't be looking at me. 35.5 times divided by 100, sorry, divided by 106.5. See, I have scientific calculator. I have that white one, that class whiz. I'm an engineering student, so that's what I use in school. But I am not using it to teach you guys because I know that your JAMB or WAEC that is now CBT, the calculator is not the same with mine. So that's why I say I'm using this my phone calculator. That is exactly how your exam calculator is. Everything your JAMB and WAEC calculator has, it has it. Anything it doesn't have, it doesn't have it. That's why I'm using it. So please be pressing with me. So times 100, that's 33.33%. Good. So chlorine is 33.33%. All right. So for my question, option C is correct. Good. All right. So let's move to question 10. You see question 10 on your screen now. Question 10 says, determine the percentage by mass of iron in iron 3 oxide. All right. Iron 3 oxide. So iron 3 oxide is Fe2O3. Iron 3 oxide. Now we're looking for the percentage by mass of what? Iron. Do you understand? And they gave us that iron is 56, oxygen is what? 16. So the percentage by mass of iron will be equal to, what's the molar mass of iron in this case now? 2 multiplied by 56 divided by what? 56 divided by the molar mass of this whole thing. So it's going to be 2 multiplied by 56 again plus 3 multiplied by 16 times 100. Do you understand? It's simple now, be ahead. So well, me, I will just, okay, don't go and say this one here cancel, this one here cancel. That's mathematical blunder. So do it first. So percentage by mass of iron will be equal to, what's this up? 2 times 56 is what? 112 divided by 112 plus 48, 160. So this multiplied by 100 should give you my answer directly. So what's the percentage going to be? 112 divided by what? 160. Pressing now, don't look at me. Times 100. Yes, I'm talking to you that is looking at me without pressing. Times 70. So that's 70%. So the percentage of iron present in iron 3 is 70%. And for my option A is correct. Alright, so I hope that's cleared. So this is question what? 10. Alright, so question 11 will appear on your screen now. And it says, what is the percentage by mass of carbon in Na2CO3 H2O. We have done this already, but I don't think it was carbon, it was nitrogen, it was sodium that time. Okay, so this is sodium trioxocarbonate 4 decahydrate. All right, so we're talking about the percentage by mass of carbon here. So let's just do it very quickly. Pay attention. You know, let me even tell you something. I think this question asks to find the percentage by mass of oxygen. Do you know that you have to find the oxygen molar mass here and also find it here too and add them? Do you understand? So let's do this. So this gives me 23 times. Let's just go straight to the point. So the molar mass, let me go to my calculator. The molar mass of this guy is equal to, so 23 times 2 is 46 now, plus this gives me 12, this gives me 48, and this gives me, this is 48, 3 times 16, and this is 18. We have done this already. Abi times 10, that's 180. So this gives me what? So the molar mass is equal. So you need to be a chemistry student that you just be solving questions. I'm like, how do you know that this is this? Have you calculated it? It's because you have been practicing. By now, you should know that CO2, molar mass of CO2 is 44. Do you understand? By now, you know that S is 32. Iron is this thing. This one is, you get what I'm trying to say? So that's basically how all these things work. Okay? So add them up. This gives me 46 plus 12 plus 48 plus 180. That's 286, like we got before, gram per mole. So this is the for this whole thing. Now the molar mass for this whole thing. Now carbon in this thing is 12. So the percentage of carbon present is equal to 12 divided by what? 286 times 100. That's the answer. So 286, 12 divided by 286 times 100. That's 4.19 or 4.2 approximately percent. Yeah. So for my option B is correct. Okay, now let's move to the next one. Question 12. You see the screen now. Question 12 says, what is the percentage by mass of aluminium in Al2SO4 3? So what's the percentage by mass of aluminium in this guy? Okay, so very, very simple. This aluminium now, aluminium is what? From the question, they gave it as 27. So this is 27, so times 2. So let's just find the molar mass of this guy. 27 times 2 is what, class? Press, 54. Plus, now this 3, this sulfur, normally it has 1 atom here. But since this 3 is here, that means it's going to multiply it. So it's going to be 3 atoms instead. So 3 times sulfur is what? 32. That's 96. Plus, so oxygen is 4 times 3, 12, right? 12 multiplied by 16. I hope we are getting it. If you don't understand, please just ask in the comment box. See, oxygen here is 16. I mean, oxygen atom here is 4. This 3 that is multiplying is now making it 12. So 12 times the relative atomic mass, which is 16, gives you what? 192. So it means that this whole thing, when you add them up, 96 plus 54 gives me 342 grams per mole. Now 342 grams per mole is the molar mass of this compound. But the question has to find the percentage of aluminium. So percentage of aluminium will be, aluminium is 54 in this thing. That's the molar mass of aluminium in this compound is 54. This thing times 100%. Okay, so what is it going to give me? 54 divided by 342 times 100. That's 15.8%. So the percent of aluminium is 15.8%. Very, very simple question like this. Very simple. Option A is correct. I hope that's clear. Now let's continue. Question 13. You see question 13 on your screen now. Please pay attention. This one is a bit tricky. Pay attention. Now, question 13 says, what is the value of X in the molecular formula Pb This is question 13. So what's the value of X in the molecular formula PbNO3X? Okay. If the percentage by mass of nitrogen is 46, is 8.46. So the percentage of nitrogen, they already told that is what? 8.46%. A 1, B 2, C 3, D 4. Now pay attention. Pay attention. Let me explain something to you. Let me change things to X so that you guys will understand what I wrote here. Now, hey, if it is now 2x. Now, please pay attention. They told you to find the value of X if the percentage by mass of nitrogen in this whole compound is what, class? 8.46. Now, this X that they asked you to find is something that is all those things that is here. All those things. So imagine that, listen. Imagine that we don't know the value of 3 here. And they asked us to find 3. How can we do that? Now, that's what this question is telling you to do. Now, pay attention. Let me explain something to you. The percentage by mass of nitrogen in this entire compound is 8.46. And remember, from the formula for percentage by mass, percentage of nitrogen is going to be equal to the molar mass of nitrogen in the compound, listen, divided by the molar mass of the entire compound. Multiply by what? 100%. This is the formula for percentage by mass. So, now, they have already given us that this thing here is 8.46. It will now be equal to, what's the molar mass of nitrogen? See, the molar mass of nitrogen normally, what's the molar mass of sulfur here? It's going to be 1 times, you multiply this 3 first, Abi. Then you now say, okay, since, like I said before, this was initially 1 atom, but it became 3 because of this 3 outside. That's 3 times 1. Then you now say 3 times 32. That's what gives you this one. But in this case, we don't know what this thing is. So the molar mass of nitrogen in this compound is going to be what? Normally it's going to be 14 times. I think this was 1. It's going to be 14 times 1. So this is going to be 14x. Do you understand? I'll go again. I'll change again. Listen. The molar mass of nitrogen here is 14. Right? 14 times 1 atom. But remember, I always meant to multiply the number of atoms with this one that is outside. So that's more like saying you're having nx. So how can you find the molar mass of nx? The molar mass of nitrogen normally, the relative atomic mass is 14. So times x, that's 14x. Divided by the molar mass of the entire compound. Now, how can we get the molar mass of the entire compound if we don't know the value of x? We can get that. Just pay attention. You are going to solve normally like you want to find the molar mass of a compound. Okay? So, what they tell you lead is 207. So, this is Pb. This X is not affecting the lead. So, this is 207 times 1 because it's 1 atom of lead. Right? So, 207 plus this one now. This thing is just more like saying NXO3X. Do you understand? So, 14 times X. 14x plus this is 3x, so 3 times 16, 3x times 16, that's the relative atomic mass of oxygen. That's what? 16x. Right? What is left? Sorry, 48x rather. I know I was writing the wrong thing. So 48x. Okay, so now this is looking like a normal mathematics problem. So multiply by 100%. That's this guy. All right. Now, what's the next step? The next step is to try to divide this guy. Divide this 100. Like do this divided by this. Do you understand? So 8.46 divided by 100. That gives me what? 0.0846. Now equal to 14x divided by 207 into bracket plus, add this thing up. This gives me what? 62. x into bracket. Now, what's the next step? Cross multiply. Let me use another marker so you guys don't get confused. So cross multiply. This give me 14x equal to 0.0846 into bracket 207 plus 62x. Now, let's solve properly. Mathematics. Now, this is 14x and is equal to, so 0.0846 multiplied by 207 gives me 17.5122 plus 62 times 0.0846 gives me 5.2452x. Are you getting it? Now, bring this one here. So it's going to be 14 minus 5.2452. So 14 minus 5.2452. That gives me 8.748x equal to 17.512. Finally, what's my x going to be, class? This divided by this. Let's press 17.512 divided by 8.748. 2.00 approximately. 2.0. Correct. So it means that this my x here is what? 2. From our option B is correct. Okay, so let's move to question 14. I hope this is clear. Very simple. Just the molar mass of the nitrogen divided by the molar mass of the entire compound, multiply by 100, apply the knowledge here, you solve. Okay, so this is basically the answer. And let's move to question 14 now. Now 14 will appear on your screen now, and it says, this is the last question on percentage by mass. So it says a gaseous metallic chloride McLX consists of 20% by mass of M. So 20% by mass of M. The formula of the chloride is, so it means they're asking us for the formula of the chloride. That means we have to find this value of X to know the formula of the chloride, just like what we did before. So they have given that the percentage by mass of this M is 20. So let's write percentage by mass of M equal to the molar mass of M in the compound divided by the molar mass of the entire what? Compound times 100%. Are you following? Good. So the percentage by mass of this derivative is 20 equal to, let's divide this body into 2, equal to, what's the molar mass of M? They told you the question, 27 divided by, now the total molar mass 27 plus this C. Remember, this X is where the Cl is, so 35.5x. Do you understand? Cross multiply. Sorry, times 100. So this 100, let's bring it here. So divide by 100. Do you get it? So this is 0.2 equal to 27 divided by 27.35.5x. Now, what do we do, class? We cross multiply. Abi now. So this gives me 0.2 into bracket 27 plus 35.5x. Okay? Equal to 27. Do you understand? Equal to 27. So 0.2 times 27 gives me what? It gives me 5.4. So this is 5.4 plus 0.2 times 35.5, 7.1 equal to 27. I hope we are getting it. 7.1x. So now I'm having 7.1x to be equal to 27 minus 5.4. So 27 minus 5.4, that's 21.6. So what's my x going to be finally, class? 21 divided by 7.6. 7.1 rather. That's 3.04, approximately 3. So it means that my x is 3. Then the formula of this compound is MCl3. 3. Option C is correct. Option what? C is correct. Good. I hope this is very clear. This is very simple. So that's basically all the 14 questions we're going to solve today on percentage by mass. I hope you understand. And please, if you are just new to my channel, please do have to subscribe, like, share to your friends. And if you want to learn more about Ajaks tutorials paid classes, this is my number on the screen. Text me on WhatsApp to be part of our paid classes for JAMB, WAEC, NECO, post-UTME, 100 level student, JUPEP candidate. Text me on WhatsApp. We run tutorials for all of you. Okay, so let's continue.
Hi everybody, my name is Ifeogene Godrinet. I had a JAMB score of 341 and my experience at Ajaks tutorial was very wonderful. The scores were very good, especially my English, I was so glad with my score. And my advice to 26 UTME aspirants is that for them to sit down, to buckle down and make sure that they give their best and their all in the exam.
Empirical formula. A molecular formula. Now, empirical formula. What is empirical formula? This is actually empirical formula. Empirical formula. So this is I. So what is empirical formula, class? Empirical formula is basically, you see the screen, the simplest whole number ratio. The simplest whole number ratio of atoms of each element in a compound. So it is the simplest whole number ratio. Now, the question we just finished solving now. MCl3. MCl3, what's the ratio of each atom? 1:3. This is the empirical formula. Okay, this is the empirical formula. So, because there is no how you want to break down 1:3 again. So, empirical formula is the simplest whole number ratio. The simplest whole number what? Ratio. Now, let me tell you something. If you have something like this, this is how a molecular formula can look like. So that molecular formula, all right, molecular formula is basically the actual number of atoms of each element in one molecule of a compound. That means this O element now, right? If you break this down, you'll be having MCl3 into what? 2. The total compound here is the molecular formula, but the simplest is the what, class? Empirical formula. I hope that's clear. Now, there are steps to solve empirical formula questions. Step 1, write down, they will give you either mass or either percentage. Anyone they will give you. So step 1, write down the mass or percentage of each element. So after I finish writing it down, secondly, you divide each of them by the relative atomic mass. Don't forget that. You must divide each element by the what? Relative atomic mass. The next one, you divide each mole value by the smallest of them. So dividing the mass or the percentage of each respective element by its relative atomic mass is so that you can get the what? The mole. So when you have gotten the mole, you now start dividing each of them by the smallest. So if you are having, let's say, this still the same MCl3, okay? Let's say you got this one mole to be 1 mole and you got this one mole to be 0.7 mole. So what's the smallest? 0.7. So you start dividing each of them. So 1 divided by 1, 0.7 divided by 1. Divided by 1 divided by 0.7, 0.7 by 0.7. Why? Because the smallest. So you should always divide by the smallest, okay? And after that, you now express it in whole number. Express it in whole number. That is, if you are having, let's say, 0.9, you approximate to what? 1. If you are having 0.7, you approximate to what? 1. but there's something that you need to know. There's something you need to know. If you're having 1.5, you don't approximate to 1. You don't approximate to 2. You don't. No. If you're having 1.5, this is the same thing as saying 3 over 2. Then you cross multiply. We'll do it to 3. Okay? Now let's get into the video. Empirical formula. Firstly, we'll solve one example, and I'll use that as example to explain molecular formula. Then we'll now start solving past questions from question 15. Alright, so welcome back. Now let's start with an example that I'll use to still explain molecular formula. So the example will show on your screen now. They said okay. Now, a compound contains 40% of carbon. Okay? 6.7% oxygen, hydrogen, and 53.3% oxygen. Then I told you that if this compound has a molar or a molecular mass is same thing as molar mass. So molecular mass of 180 grams per mole. If it has a molecular mass or molar mass of 180 grams per mole, what is its empirical formula, and what is its molecular formula? So we have to find I, empirical formula, and molecular formula. Okay, now please follow me attentively. First of all, what's the first step I told you? I told you that if you are giving, sometimes you might be giving grams, sometimes it might be mass. All these things might be mass. So it's still the same thing. Don't shake. It's the same thing I want to do now. Let me use the way your secondary school will be doing it, or the way you were taught in secondary school in SS1, but we'll not be doing that here. But I'll just teach you for the first time. Alright, we'll do it for this first question. Hydrogen, oxygen. Now, what is my step 1? First of all, now we want to first find the empirical formula, because you cannot find the molecular formula without finding the empirical formula. So first of all, write the percentage. This is 6.7. This is 5.3.3. Now, after that, what's step 2? You divide by each of the element relative atomic mass. Now, we'll get our answer here. So 40 divided by 12, press. 40 divided by 12, this is 3.33. Are you getting it? 6.7 divided by 1, this is 6.7. 53.3 divided by 16, this is 3.332. Now, so 3.33. Now, what's the next step? So all these things that we got now are what? Moles. So that's the reason why you have to divide by each element related to atomic mass to get the mole. Remember, mole is mass over molar mass. I told you. So after you have gotten this, the next step is to divide each of them by the smallest mole. So out of all this one now, what is smallest mole you are seeing here? Some of them they have the smallest mole. So divide everything by this 3.33. Are you getting it? So this gives me 1. This gives me 2. If you press the calculator, this gives me what? 1. Class. 1, 2, 1. What you got now are the ratios of this compound, of this element in the compound that is formed, that is having a molar mass of 180. So it means that this thing is in ratio 1, this is in ratio 2, and this is in ratio 1, giving what class? CH2O, the empirical formula. Are you getting it? This is the empirical formula. Now, listen, we're not done. We have gotten an empirical formula as that. How can we get molecular formula? Class, note this formula down. That the molecular formula is equal to empirical formula into bracket N. Now pay attention to this. Note that when you now want to solve, this is an expression. But when you want to solve to get the value of N, you now apply molar mass. Listen to this. This is still the same thing as saying the molar mass of the molecular formula is equal to the molar mass of the empirical formula into bracket what? N, where N is the value. I hope that's clear. So the molar mass of the molecular formula is equal to the molar mass of the empirical formula times N. Do you get it? Now, please pay attention. We are moving somewhere. Now, let's use this formula to find the value of N. Then from there, we can get the molecular formula. This, remember, like I said, this is an expression. This is the molecular formula. This thing here. Empirical formula bracket N. But now, to find this N, you use this one. Do you get? Good. So write this in your notes. Okay? Now, what's the molar mass of the molecular formula? They already told you that the molecular formula is the entire formula of the compound. So they already told that the molar mass of the compound is 180. So this is 180 equal to, what is the molar mass of the empirical formula? This is the empirical formula here. CH2O. And carbon is 12. Hydrogen is 2 here, right? Oxygen is what? 16. Right? 12 plus 2 plus 16. This is 18. This is what? Let's press. 12 plus 2 plus 16. This is more 30. So 30 grams per mole is the molar mass of the what? Empirical formula. N. Now, what is my N going to be finally, class? My N is going to be equal to what? 180 divided by what? 30. And this is going to give me what, class? Cancel, 6. Now, my N is 6. Now, from this thing, the molecular formula is equal to empirical formula bracket N. I can now get my molecular formula by saying my molecular formula is equal to CH2O into bracket what? 6. Therefore, molecular formula is what? C6H12O6. Good done. So the empirical formula is CH2O and the molecular formula is what? C6H12O6. That's the answer. So I hope you understand empirical formula, molecular formula now, because we're moving straight to JAMB questions, no wasting of time. Question 15, let's go. So let's look at question 15. You see it on your screen now. Question 15 says, the chloride of a metal M consists of, so the chloride of a metal M consists of 79.78% of chlorine. So when you see something is a chloride, that means it is a metal with chlorine. Do you understand? So the chloride of, because it will undergo what? Electrovalent ionic bonding. Okay? Now, that doesn't mean chlorine cannot undergo others like HCl, NH4Cl. That doesn't mean, but when you're hearing chloride, that's basically what it means. A metal and chlorine. Okay? So the chloride of this compound contains 79.7% what? Chlorine. Now, by mass, what is the empirical formula of the chloride? So my options are showing MCl3, MCl, MCl2, M2Cl3. Now, how can you solve this? What's the empirical formula of this chloride? So I told you that the chloride will contain what? The metal and chlorine. So M and chlorine. Now, if you recall when I was teaching you percentage composition, I told you that when you add the percentage composition of all the elements present in a compound, it must give you 100. Because in this question, a chloride contains M and this. This is what the chloride contains. The compound M, I mean the element M and what element? Chlorine. But this one, they only gave us the percentage by mass of chlorine. We can get the other M. Why? 100 minus this thing gives me what? The percentage by mass of M. That's how it is, because I told you it must sum to 100. So let's do this. 100 minus 79.78. So this is 20.22% of M. Right? Now we can now solve. We have to find the empirical formula. That's all. So we just use the normal way I taught you. Right? The normal way I taught you. I don't do that table, but let's do it. So MC, right? Please follow me. So what's my M? My M is 20.22. What is my chlorine? 79.78. Are you following? Me? So what's my molar mass of this guy? I mean, the relation atomic mass they gave us now. Told us is 27. Do you understand? This one is what? 35.5. So this gives me what? 20.22 divided by 27. This gives me 0.75 approximately, right? 79.78 divided by 35.5. This gives me 2.252 approximately. 2.25. Okay? So these things that we got now, what? The mole. So what did the question say? I mean, what I taught you that always divide by the smallest mole. So what's the smallest mole here? This one. So divide both sides by 0.75. This gives me 1. 2.25 by 0.75. 2.25 divided by 0.75 gives me 3. So it means that the empirical formula of this compound is MCl3. M1Cl3. So that's MCl3. Okay? I hope this makes sense. So let me even teach you a trick in your exam. You don't even need to solve this question if I were you, because they already told us that the relative atomic mass of M is 27. 27 is aluminium, and aluminium has a valency of 3. Chlorine has a valency of what? -1. When they cross multiply, it gives what? AlCl3. So this is MCl3. Don't need to solve. So that's if you understand. It's good to even know it, so that you waste your time. I mean, it will not waste your time. Okay. Now let's look at the next question. So open your screen now. Question 16. Question 16 says, an oxide of nitrogen contains, so an oxide of nitrogen, it means nitrogen and oxygen. Do you get? A chloride of a metal means chlorine and a metal. Good. So an oxide of nitrogen contains 69.6% of oxygen by mass. All right. So 69.6% of what? Oxygen. Okay. Its empirical formula is, so if it is an oxide of nitrogen and this is just the one for oxygen, then by subtracting this from 100, I'll get that of nitrogen. Right? This gives me what? 100 minus 69.9. 100 minus 69.9.6 rather. That's 30.4%. So this is for what? Nitrogen. Okay? Then we can now do. You guys, I told you I will not do this thing, but let me just do it. So nitrogen is 30.4. Oxygen is what? 69.6. Divided by what? In relative atomic mass? 14. 16. Abi now? So this gives me what? This gives me 2.17. Don't approximate here. Don't. It's only when you get to here you now get the whole number. Do you understand? Good. So this one 69.6 divided by 16. This gives me 4.35. So this is my what? My mole. I'm always writing it so you guys don't forget. And let me tell you one common trick many of you make. Many of you, you always forget to divide through by the mole. The smallest mole, you forget it. Because sometimes you solve and you get maybe here as 2, you get me here as 1. You now say this is NO2. No. You have to still divide. Okay? So, dividing, what's the smallest? This is the smallest. So, dividing through by 2.17. This gives me 1. And 4.35 divided by 2.17 is 2. So it means my empirical formula is what? NO2. Yeah, that's it. That's it. Option D is correct. You can see how simple it is. Okay. Now question 17 to appear on your screen now. Okay, question 17 is very sweet. Listen attentively. It says, upon heating 1 dm cube of a monoatomic gas. Now, when you say gas is monoatomic, it means that that particular gas is how do I put this in English now? That means O, this is monoatomic. O2, this is diatomic. Do you get? So that's basically what it means. All right. So upon heating 1 dm cube of a monoatomic gas, why? It combines with 1.5 dm cube of oxygen to form an oxide. So it means that Y was heated with oxygen. Oxygen is diatomic to form an oxide. Now, the empirical formula of the oxide is, so now let me tell you something. Listen attentively. This particular question is under what we call Avogadro's law of combining volumes. All right, and Avogadro's law of combining volumes states that, listen, it says that when two gases are reacting, or when there is a combination of two gases, all right, the ratios of their volume is equal to the ratios of the moles, provided that the standard temperature and pressure are kept constant. So this one, he told us that 1 dm cube of this guy, this one was what? 1.5 dm cube. Now, the question asks us to find the empirical formula of this particular compound. Now, let me explain something to you. Listen attentively. From Avogadro's law of combining volumes, it says this volume, all right, when two gases are combining or are reacting, the ratios of their volume is still equivalent to the ratios of their mole. 1.5. So this means that, listen, this means that this is 1 mole and this is what? 1.5 mole. So it brings, this place brings us here directly. So what's the next step from here? You divide through by the smallest mole. The smallest mole is 1. 1 divided by 1 is 1. 1 divided by 1.5 is 1.5. So it means that my Y and my O, this is 1 and this is 1.5. That's after division. That's here. So it means my empirical formula is going to be something like YO 1.5. Now, this doesn't make any sense. Doesn't make any sense. If you remember, I told you that when you are seeing 1.5, 1.5 means 3 over 2. Now, it makes more sense. I can cross multiply. And when I bring this, when I cross multiply, I'll bring in this 2 here. And this my 3 is remaining here. So what's my empirical formula, class? Y2O3. Correct! Option A is correct. This is a very, very tricky JAMB question though. So don't forget, Gay-Lussac law of combining volume, it states that, or Avogadro's law of Gay-Lussac or Avogadro's law of combining volume, it says that when the same volume, when two gases, alright, or two more gases are reacting, the volumes, the ratio of their volume is equivalent to the ratio of the mole. That's why, don't worry, maybe in like series 3, we'll solve a question on gases and we'll not be able to use their moles. We'll convert the volume to the mole. So that's basically what it states. That's Gay-Lussac's law of combining volume. Okay? So I hope this is clear. Let's move to question 18. Alright, so let's look at question 18. So I'll play your screen now. Now, question 18 says 5 grams of an oxide of a metal M. So 5 grams of this oxide of a metal M. That means if it's an oxide of a metal, it means the metal is having an element of M and oxygen in it. I mean, the compound is having an element of M and oxygen. So 5 grams of this particular compound gave 4 grams of the metal M. So 4 grams of metal, 5 grams of this metal, of this oxide gave this guy. So what else? When reduced with hydrogen, okay, normal reaction, doesn't mean hydrogen is in it. Listen, what is the empirical formula of the what? Oxide. Now, 5 grams of the oxide gave 4 grams of the metal. So it means 1 gram of oxygen is present in 5 grams of the oxide. See, interpretation. 4 plus 1 gives you 5. That's it. So now we have mass instead of percentage like we were having before. So this is my metal. This is oxygen. This is what? 4. And this is what? 1. What do I say I should do first? Divide through by what? Divide through by what, class? The molar mass. I mean the relational atomic mass. So the M that is given is what? The M given was what? 64. And this one here is what? 16. So 4 divided by 16, 4 divided by 64 rather, that's 0.0625. 1 divided by 16, 0.0625 again. Hey. So what are we doing, class? Divide through by the smallest, 0.0625. This gives me what? 1:1. So it means that my oxide is M1O1 and it's same thing as saying MO. From my option what? A is correct. I hope this makes a lot of sense. Okay, now let's move to question 19. Question 19 will appear on screen now. It says what is the empirical formula of an organic compound containing 40% of carbon, so 40% of carbon and 6.6% of what? Hydrogen. Okay, by mass. So what is the empirical formula of an organic compound containing 40% of carbon and 6.6% of hydrogen? If you look at the options are A, CH2O, B, CH2O3, C, CH2O5, and D, CH4O. So it means that there is oxygen, but it did not give us the percentage of oxygen. I told you the percentage of each individual element in a compound must sum up to what? 100. So 40 plus 6.7 plus something must be equal to 100. So I can basically get percentage of oxygen by saying 100 minus the sum of these two things. That's what? 46.67. This gives me what? So let's press 100 minus 46.67. This gives me what? 53.3%. I think we did this before. We did something like this before, right? Yeah, we did something like this before. So what is the empirical formula? Carbon, hydrogen, oxygen. Right? This is 40. This is what? 6.67. This was 53.3. Okay? Divide this by what? 12 divided by 1 divided by what? 16. This gives me what? 3.33. I've done it before, I remember. 6.67. And this is what? 3.33. Okay? So divide through by what? Smallest. So this is my mole. So divide by the smallest mole. So it means that At the end of the day, I'm going to be getting what? Here's 1, here's 2, here's 1. So what's my empirical formula? CH2O. Okay? Yeah, CH2O is correct. Option A is correct. Good. Now, question 20. You see it here. Question 20 says, an element A has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. So it has the electronic configuration of this. The combination of this element A with a halogen X can give which of the compounds shown. Now, this is a very, very simple question, but many people might actually fail it because of your knowledge on valency. Now, it's what we call ionic configuration. It's what we call orbital configuration, and it's what we call electronic configuration. So this is electronic configuration, okay? So orbital configuration is the one that's like this. All right. 1, 2. Remember Hund's rule. Then 1, 2, 3. But it's only 1. So this is the orbital configuration. Now, the ionic configuration is where I want to teach you something on now. Listen attentively. The ionic configuration, I will show you what it means. Ionic configuration is where you can be able to easily know the valency of an element. Now, let's find this element. What's this element? 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 1, 13. It means this element is what? Aluminium. Aluminium is number 13 in the periodic table. Okay? So the element is aluminium and it's number 13. Now, even if you don't even know the element, it's not a problem. So aluminium is number 13. Now, the ionic configuration. This is me digressing a little bit, but it's good. Configuration. Now, it is 13, Abi. 2, 8, 3. This is the ionic configuration. 2, 8, 3. Yeah. So the ionic configuration is saying that in the duplet, in the first shell is duplet. The second shell is octet. So it means that in the first shell, the total number of electrons here must be 2. In this one, it must be 8. No, it not must be 8. It should not exceed 2. It should not exceed 8. And so on like that. KLM, all those things. Now, so listen attentively. Note that the number of electrons in the outermost shell is the valency. And it is that valency that's the combining power of an element. And that combining power basically means what is going to give the other element is from the valency you will know. Now, ideally, I'm already seeing that my valency of this aluminium is 3 because this is 2A3. You can't get it from here. You might get confused. So it's better you write the ionic configuration, or you want to draw like this again. So this is 10. So 2 more anywhere you want to put it. So this, 3 more, sorry. So this 1, 2, 3 is the valency of what? Aluminium. So it means that the combining power of aluminium is 3. And they said an halogen. All halogens have a valency of 1. Because let's use chlorine for example. Chlorine is number 17. 2, 8, 7. Now this 7 is not basically the valency. This 7 means that there are 7 electrons here, but it needs one more to complete it. Do you get? So that's why it has a valency of what? 1. So this is chlorine. With the electrolyte is chlorine. Let me not be forward. It's an halogen. All right, halogen, and it has a valency of what? -1. So this is 3 and this is 1. Cross multiply. Al what? H3. So this Al, remember they not tell us it's ALO. It's me that is just telling you now. They told you that it's what? A. So A, and they told you the halogen is X. X3. Option C is correct. I hope this is very, very clear. So that's basically what you can basically do with this question. Very, very simple. Once you understand orbital configuration, you understand all these things, you should be able to know the valency of any element. Okay? So let's move on. This question what? It's question 20. So question 21, let me rub off the board.
Ajaks Tutorials is more than just an online tutorial. It's a community built on innovation, hard work and excellence. Ajaks Tutorials has consistently set the pace for academic success, tripling her records every year and guiding countless students into their dream institutions. In 2024, Ajaks Tutorials produced 75 students with 300 plus, with the top students emerging 9th nationwide. In 2025, the number soared to 238 students with 300 plus, with the top students ranking 8th in Nigeria. And in 2026, Ajaks Tutorials is set to do even more. Through well-structured online classes, expert tutoring and personalized support, Ajaks Tutorials is redefining quality education. Ajaks Tutorials is headed by Ajakaye Joseph Oluwaseun, the CEO, founder, and a passionate educator and educational consultant, along with his powerful team of seasoned tutors. To be part of the next success story, contact us via the number displayed. Join Ajaks Tutorials today.
So now, welcome back. Let's look at question 21. It will appear on your screen now, and it says the molar ratio of hydrogen to carbon is 2:1. So hydrogen to carbon is 2:1. So they have already gotten an empirical formula for us. And what's the empirical formula, class? Always start from C. So C H2, yeah, 1:2, 2:1, same thing. They said this is this, this is this. So do you understand? Carbon is 1, hydrogen is what? 2. Okay, now on evaporation at STP, that's when it's evaporated at standard temperature and pressure, 0.24 gram of the compound, so 0.24 gram of CH2, all right, it produced 64 centimeter cube of vapor. Now it produced 64 centimeter cube of vapor. What is the molecular formula of the liquid compound? So this is the empirical formula. We have to find the molecular formula of this compound. And recall that the molecular formula is equal to what, class? The empirical formula multiplied by N. So it means if we can find N, we are good and ready to find the what? Molecular formula. How can we do this? Pay attention. First of all, you need to understand this question. 0.24 gram of this liberated this vapor. What is the molecular formula? You know, I told you that this is an expression. But if you want to do your actual calculation, then you now start involving what? Molar mass. So I told you that this thing still means the molar mass of the compound. Are you getting it? This is not 0.24 of this. This is actually 0.24 of the actual compound. This is just an empirical formula. So this is of the compound. Okay, so molar mass of the compound is equal to the molar mass of the empirical formula all in brackets what? N. We can easily get the molar mass of the empirical formula, all right, by saying 12 plus 2, that's 14. But how can we get the molar mass of the compound? Class, listen. In the series 1, I told you, I gave a formula. I said mole is equal to mass over molar mass. And I still told you that this same mole is equal to the volume of a substance over volume at STP. Alright? And now, we know the mass. We know volume at STP as 22.4. We know the volume, they gave us 64 cm cube, but we'll convert it to dm cube. If we get our molar mass, we'll plug it here and we'll get N and we'll get molecular formula. Now let's solve. What's the mass? 0.24 divided by the molecular formula of this compound is equal to the volume. So this is 64 cm cube. Please always convert to dm cube. And I told you in the previous video, go and watch it. From cm cube to dm cube divided by 1000. I'm not going to say anything I said in that video. Go and watch it. 64 divided by what? 1000. That's 0.064. Alright? Divided by volume at STP is 22.4 dm cube. So from here, we can cross multiply and say that my molar mass is equal to 22.4 times 0.24, right? Divided by 0.064. So this gives me what? What's the answer, class? 22.4 times 0.24 divided by 0.064. 84 grams per mole. Now, 84 grams per mole is my molar mass, right? That's my molar mass. So, we'll put it here. 84 will now be equal to 1 emission to find N. What's the molar mass of empirical formula? This is 12, this is 2. 12 plus 2, 14. Be fast, no time. So what's my N, class? My N is going to be what? 84 divided by what? 14. And my N is what? This give me what? I press 84 by 14? 6. So it means that the actual molecular formula is equal to what? Remember, it's empirical formula times N. This is the main expression. So empirical formula is CH2 and my N is what? 6. So this is actually what? C6H12. So this is what? C6. Hey! From our option D is correct. Okay, so I hope you are enjoying this video. Please, if you are enjoying this video, do well to like, subscribe, and share to your friends. Question 22. It will appear on your screen now. It will appear there. Question 22 says, which of the following is correct for compounds of an element Y having a combining power of 3? Told you. The combining power is the valency. So they told us that this particular Y has a combining power of 3. And from the options, we are going to see that the other element there is oxygen. Don't forget, oxygen has a combining power of 2. Don't forget that. -2 actually. That's why it's O. That's why it's O2. Do you understand? So this one, I tell us the combining power of 3. That's why. Alright, so cross multiply. This gives me what? Y2O3. Option B is correct. Very, very simple, something like this. Okay? I hope you enjoyed this video. Question 23. You see it on your screen now. It says, an element E forms the following compound with bromine, EbR2, EbR3, and EbR4. The observation illustrates A, the law of conservation of mass, the law of definite proportion, the law of multiple proportion. Now, the answer is the law of what? Multiple proportion. Now, let me tell you something about multiple proportion. Multiple proportion is when you are having a compound, all right, producing producing as many, okay, when you're having an element producing as many compound as possible. So that same element is giving this one is giving this one, just like what they said, EBR2, EBR3, EBR4. That's multiple proportion. Do you understand? So that's basically it. Conservation of mass, we know what it means. Definite proportion, we know what it means. So that's basically the answer. Multiple proportion is correct. EBR2, EBR3, EBR4. Just know it's multiple proportion. Use something like this again. It'll tell you that this one produce so mass, and this same thing again produce so mass, and this same thing again produce so mass. That is multiple proportion. Okay, good. Question 24. Good. All pure substances or pure sample of the same compound contain the same number of elements in the same proportion by mass is a statement of this is what? Definite proportion. Okay, definite proportion is correct. So you can see the difference now. Definite proportion says that all pure samples, all right, it's containing the same proportion by mass, okay, in definite proportions. So it is the law of definite proportion. Then this one is, the other one is law of multiple proportion. Okay, then the conservation of mass basically tells us that energy can neither be created nor destroyed. All right, good. All right, so let's look at question 25. You are going to sit on your screen now. Question 25 says a sample of a substance containing only carbon and hydrogen burns in excess oxygen. Pay attention. It yields 4.4 grams of CO2 and 2.7 grams of H2O. The empirical formula of the substances: A, CH3, B, CH4, C, CH2, and D, C2H4. Let's solve very well. Now pay attention. This told us that this particular compound was burnt in oxygen. It undergone a combustion reaction, all right, and it was burnt to give CO2 and water. Now, it tells us that CO2 is having 4.4 grams and water is having 2.7 grams. What is the empirical formula of C and H? To find the empirical formula of C and H, we must first find the separate masses of carbon here and the mass of hydrogen here. Now, how can we get the mass of carbon here? It's very simple. I will teach you now. Pay attention. For what you are seeing here, let's first find the mole. 4.4 divided by the molar mass of CO2, we should know is 44 by now. This gives me what? 4.4 divided by 44. I know it's 0.1, but I just want to press a calculator. So 0.1 mole of CO2. Now, class, let's find the mole of carbon present in this compound. Now, how can we find the mole of carbon? Pay attention. From what we were doing in series 1, 0.1 mole of CO2, 1 mole of carbon, 1 atom of carbon in CO2. Okay, 1 atom is present in 1 molecule of CO2, right? So it means that how many moles of carbon now present in what? 0.1 mole of CO2. Cross multiply. You're going to get your X as what? 0.1 mole of carbon. Okay, so from mole equal mass over molar mass, the mole is what? 0.1. All right, and what's the mass? What's the mass, class? The mass is what we're looking for divided by the molar mass of carbon is 12. Cross multiply. So the mass of carbon present in 4.4 grams of CO2 is what? 1.2 grams. All right, now let's find the mass of hydrogen. The same step. First of all, mass of hydrogen using the same step. First of all, water is 18. So 2.7 divided by 18. This gives me what? 2.7 divided by 18. It gives me 0.15 gram. Sorry, mole. 0.15 mole. Alright? Now, so this is the mole of water. And from this water, you are going to see that 2 atoms of hydrogen is present in 1 molecule of the water. So how many atoms, or how many moles, sorry, how many moles, this series 1, oh, how many moles of hydrogen is now present in 0.15 mole of water? Okay, cross multiply, you have that x equal to what? 2 times 0.15, and this gives me what? 0.3 gram, 0.3 mole of hydrogen. Now 0.3 mole of hydrogen, from molecular mass of mass equal to from molecular mass of molar mass. So this is the mass of hydrogen divided by the molar mass of hydrogen, which is what? 1. Cross multiply, it means mass of my what? Of my hydrogen that is present in 2.7 gram of water is what? 0.3 gram. Now we have gotten mass of carbon as 1.2. We have gotten the mass of hydrogen as 0.3. Let's find the empirical formula. In fact, we can easily just use the moles to find the empirical formula, but I have my reasons why I taught you how to find mass, because sometimes they'll give you oxygen and they'll give you the entire compound, so you have to subtract, like question 26. We'll see, don't worry. So the mole of carbon is 0.1 and the mole of hydrogen is 0.3. From there we can find the empirical formula. Follow me. So it basically tells us that, you know, this is carbon and this is hydrogen. See, you can use your mass. So you can use your mass. If you do 1.2 divided by 12, you still get 0.1. And if you do 0.3 divided by 1, you still get 0.3. So you can use your mass, okay? But let's use the mole, because it's waste of time. So 0.1 mole of carbon, 0.3 mole of hydrogen, that one there. So divide by the smallest, 0.1 is the smallest. This gives me 1, and this gives me what? 3. So it means my empirical formula is what? CH3. Correct. For my option A is correct. But you don't. So I hope this makes a lot of sense, okay? Let's solve the last question in this video. It is just like this. Alright? By then you should be able to understand properly. Question 26. Alright, so now welcome to the final question in this video. Question 26 is to appear on your screen now. A compound containing only carbon, hydrogen, and oxygen was completely burnt in excess oxygen. The combustion produced 8.8 gram of carbon dioxide as CO2, all right, and 5.4 grams of water, that's H2O. When 4.4 gram of the compound, that means the total mass of the compound is equal to 4.4. So when it was used, so the empirical formula of this compound is what? I remember my empirical formula will contain the carbon, the hydrogen, and the oxygen, because it told us. How can we do that? First of all, just like we did in question 25, let's find the masses of each of them. So we'll find the mass of carbon, we'll find the mass of hydrogen, we'll find the mass of oxygen. Let's first start finding the mass of carbon. So where is carbon present? Carbon present in CO2, right? I mean now, so just like what we did before, 8.8 divided by the molar mass, which is 44. This gives me what? 8.8 divided by 44. That's 0.2 mole of CO2. So let's just go straight to the point. Moles of carbon. What's the atom? How many atoms of carbon are present here? 1. So 1 times 0.2. Okay, so the mole of carbon So the mole of carbon will be equal to what? 0.2 moles. Let's find the mass. Multiply this guy by 12, right? So my mass of carbon, 0.2 times 12 is 2.4 grams. Okay? Now let's find hydrogen. Hydrogen is present in water. So they say 5.4 grams of hydrogen. So 5.4 divided by 18, that's molar mass of hydrogen. Of water rather. So 5.4 divided by 18 gives me 0.3. So this is 0.3 mole of H2O. Now to find the mole of water present, so the mole of the mole of hydrogen present is mole of carbon. So to find the mole of hydrogen present, hydrogen atom present, how many atoms here? 2 times what's the mole? 0.3. So this gives me what? Mole of hydrogen to be what? 0.6 mole. Then multiply that guy by 1, which is the relative atomic mass, you get your mass of hydrogen. So my mass of hydrogen is still 0.6 grams. Now, to find mass of oxygen, oxygen is present in both CO2 and H2O. So we can basically find the mass of oxygen. We'll find it here and we'll find it here and we'll add it up. But stress, why? They told us that the entire compound is 4.4. Because the entire compound, 4.4, will give us the mass of hydrogen plus the mass of oxygen plus the mass of carbon. So the entire compound, 4.4, is going to give us equal to the mass of hydrogen, 0.6, plus the mass of oxygen, we don't know, plus the mass of carbon, 2.4. So it means my mass of hydrogen, my mass of oxygen, finally, will be equal to 4.4 minus 2.4 minus 0.6. That's 1.4. So I've gotten my mass of everything now. Everything. 1.4, 0.6, 2.4. Now we can now do finally grand finale. Finally grand finale. Class, say finally grand finale. Now let's finalize everything to get the empirical formula of the compound. So how can we do that? Carbon, hydrogen, oxygen. Are you getting it? Now, what is carbon? Carbon is 2.4. What is hydrogen? Hydrogen is what? 0.6. Oxygen, 1.4. Divide by what? The molar, the relative atomic mass. That's 12. 1, 16. So 2.4 divided by 12 gives you 0.2. This gives 0.6. And this gives what? 1.4 divided by 16. This gives what? 0.0875. So it means this is my smallest, Abi. Divide it by the smallest, 0.0875. Rather. So this is 0.2 divided by 0.0875. This gives 2.28. So this is approximately just 2. Alright? Now this one we call 0.6 divided by 0.0875. This gives 6.85, approximately 7. This one we call 1. Class, what is our final answer? C2H7O1. So it means that the empirical formula of the particular compound is what? C2H7O. Option C is correct. Hey, series 2 done and dusted, dismantled, dissected, destroyed by Ajaks. I hope this is clear and I hope we enjoy this video. Okay, so please, this one is very important. It's actually those two questions I solved, they're actually JAMB questions. So make sure you practice and go and practice more. All right. And if you enjoy this video, please to like, subscribe, share to your friends. And if you want to be a part of our paid classes, This is a tip of an iceberg. Trust me, it's a tip. What we do in our paid classes is more intensive. Okay, and our target is to help as many students as possible blast JAMB examination, WAEC, your post-UTME, your NECO, your 100-level exams, your JUPE programs. All right. I remain Ajaks, share Ajaks tutorials, and have a lovely day. Bye. 2026 Jambites come close. In 2025, Ajaks tutorials produced 239 students with 300 plus, and we had our top student emerging top 8 in Nigeria, 372 over 400, as Onyeme Samuel. Now, over the years, I've understood that many students that fail JAMB, they don't fail JAMB because they don't read. Alright, many of them, they don't have the right guidance. Ajaks tutorials 2026 JAMB classes is going to be starting January 5th and runs down till your examination. The fee for this class is 8,000 naira monthly. We have other plans for you. In case your parent or guardian want to pay for more than a month, we have the plan for you. To be a part, click the link below now, text number on your screen. Remember, in 2025, we are 239 700 plus. 2026 will not be any different. Class is for science students only, and class holds online. We use WhatsApp, Telegram, YouTube, and our mock portal for our classes. Click the link below now or text number on your screen to make inquiries and enroll. Have a lovely day. Bye.